Hi, everybody. My name is Vince Arnasia. I'm the Chief Product Officer of Five9 Software, and we're pleased to give you this webinar today. This is our normal Demo Friday webinar. This will be hosted by myself, and we've also got Rob Conley, who's our Senior Solutions Engineer, on the call. Today's topic is a new advancement for Five9. It's going to be where we discuss our REST APIs. So basically, in addition to having Cloud Manager via the interface that we provide, we're also now in a position to provide the same capabilities via fully featured REST API. So we plan to walk through that with you today, and this is for a upcoming release that we'll be discussing also during the session today. So thanks for joining and welcome. So as far as Five9 goes, a couple slides just to give you guys a sense of the company for those that aren't familiar on the call. Five9 has been in the cloud infrastructure space for over 7 years now with a product that has served many customers. Originally started out as Five9 Manager Standard, and over the years we've evolved to what is now Five9 Cloud Manager. We also have Five9 Cloud Security. And so really between those two product offerings, we provide a comprehensive cloud infrastructure management and security solution for both Hyper-V and Azure. So as customers look to embrace Hyper-V, either from VMware or further investment within Azure, our platform is a huge help, provides tremendous efficiencies. And then, of course, as customers move to hybrid with Azure, the platform is even more impactful and beneficial for the customer base. The reason why we're so entrenched within Microsoft from a platform perspective is because we have a deep relationship with Microsoft. We work with them quite often on the engineering side, on the program management side, of course, and other sides as well. And what that leads to is a platform that can help serve the Microsoft audience. As far as a look at the platform at a holistic level, you can see here the different capabilities that are offered by the platform itself. The ability to migrate from private to public, or even in cases of public to public, that's done via our cloud migration product. The management, replication, monitoring, optimization, backup, and administration features are all part of our Cloud Manager product that you'll be seeing today, and that's really where we have the REST APIs available as well. And then we have a standalone cloud security product, which allows for you to do things like implement a virtual firewall, antivirus, intrusion detection, once again on your virtual infrastructure, to not only allow for you to migrate to this type of infrastructure, but manage and secure it as well. The platform is multi-tenant, the platform is modular, and so we're rather easily able to add capabilities. And for those of the folks that are on the call that are customers, you're well aware of the advancements, the functionality that we've added over the last few years, and we're able to do that rather rapidly just because of the way that the platform is architected underneath the covers. As far as Cloud Manager goes, a different way to look at the capabilities is there's a lot of different modules within Cloud Manager. A lot of our customers tend to use some of the modules, not necessarily all the modules. So if you're really looking for a VMM replacement, then you're primarily focused on the management side, the Hyper-V management side of the platform. If you're looking for a backup capability that does enough for you, then you're looking at our backup and recovery capabilities. If you're looking at how to get to SDN, a recently added module is our SDN management feature set, which Rob will walk through as well. And so that capability exists. And that's kind of the way we built the platform, is it's all inclusive, but it doesn't all have to be utilized by the customer, whether you're an enterprise, an SMB, a managed service provider, or somewhere in between in regards to the size of the customer that is using the platform. It scales really high for number of VMs, hosts that it can manage. And of course, it allows for customers that are smaller to also leverage the platform and gain the same efficiencies. In addition to the efficiencies that it provides, because everything is within that single pane of glass, it also allows for you to lower your total cost of ownership. I think that's sort of inherent with the platform, and that all that it offers. It also allows for you to, quickly recover from disasters, misconfigurations. Once again, that's all because it's all there within this particular platform versus having to bounce around between different products, even if they are system center products or third-party products. That's where you get the operational efficiency. That's where you get the cost efficiency, and that's really the core purpose of the Five9 Cloud Manager platform. Last slide before we move into the actual demo. So today's topic is around the fully featured REST APIs. The architecture of the platform has always had APIs. We just have not made them publicly accessible. Now, because of the growth of the company and the type of customer that is trying to leverage the platform, whether that be mid-market size customers, enterprise customers, of course, managed service providers, the need for having REST APIs is becoming more and more paramount to our customer base. And so we went ahead and went through the process of documenting that and making it accessible and making it available in the upcoming release. Some of the benefits of the REST APIs in this particular context are related to if you're using VMM and you're using PowerShell scripts, this will serve as effectively a superior replacement. We've heard this from some customers that are actually doing that, and they're looking for ways to migrate to a true REST API model. And they're not able to do that in their sort of legacy environment. And so with this upcoming capability and Five9 Cloud Manager, they're able to automate their virtual infrastructure. They're able to scale a lot easier. A lot of managed service providers take virtual infrastructure up and down based on customer demand. This type of capability allows for you to do that in an automated fashion. Of course, it enables your DevOps teams to use the tools that they love because it's not tied to the Five9 infrastructure or the Five9 interface. And of course, with the REST API, you have a lot more flexibility of being able to, tie it to other things that are within your infrastructure, whether it be, service management products or operations management products, et cetera. And lastly, we are working on finalizing the version 3.3 of Cloud Manager. The REST APIs will be included in that. That's targeted towards the end of January, and other features as well. But today's focus is primarily around the REST APIs. So with that, I'm going to actually hand it over to Rob Conley, and Rob will walk you through the actual APIs and give you a sense of how they work. And in the next couple of weeks, we'll be doing another webinar targeted around version 3.3 as it goes GA, and we will actually show you the other features that are also forthcoming. So over to you, Rob.
Thanks, Vince. Yeah, so today what we'll do is we'll first take a look at the Cloud Manager on the client side. I'll show you some of the things that we're able to do, and then we'll jump into the actual API and take a closer look at how some of these things might be done through the actual API. Give me 1 second here. I'm going to share my screen here. So the first thing I wanted to just introduce you to is the architecture for the Cloud Manager. I'm not going to spend much time on this, but I just want to make sure if you're new to the product that you understand exactly the architecture and the way it works. On the left side, we have our Cloud Manager console. So this is a .NET application that you can install on any number of workstations or laptops. MSPs, for example, distribute this to their end customers so they can access a subset of their infrastructure. We have certain clients that have support departments that use this to give their support team limited access to their hypervisors. So the way it works is you have the client. The client connects to the Five9 Cloud Manager server. And what this is, it's a Windows service that is running in your environment. This Windows service can live either on a virtual machine, it can live on a dedicated piece of hardware, or you can even install the service in Azure and manage your on-prem. So that's running in your data center. You control the manager servers. And the manager server then speaks out to the hypervisors. These are your on-prem Hyper-V hosts here. We speak over one simple channel, 5671. By doing that, it makes it really easy to interconnect remote sites. So you might have various co-location centers, you might have distributed data centers that aren't on a local link in any way. Cloud Manager software complements that type of setup because it allows very easily to bring in different Hyper-V hosts from different locations. And all this communication is done over the single port. We also communicate with Azure and that same Cloud Manager server. One thing to take note here is the terms of security that you get by this design also. Anyone running the console will never ever directly access your Hyper-V hosts. They will only connect to the Five9 Cloud Manager server, and that actually takes those requests and executes them down on the corresponding Hyper-V host or up in Azure. People running the console, for example, can either use a custom login or they can use a domain login. Again, you might be able to secure some stuff by giving external users just custom logins so they don't need your domain credentials. But at the end of the day, they'll still be able to manage all your domain systems through this panel. So that's the actual architecture here. What I'll do is I'm going to go ahead and jump over into a demo of the client side itself. So give me 1 second while I jump over screens here. There we go. All right, so what you're, let me move, let's see if we can get it to work. There we go. So what you're looking at right now is it's a virtual lab. There we go. Let me make sure it's working again. Sorry about that, guys. Oh, running into little problems with the GoToMeeting here. Sorry about that. Doesn't want to show my application. All right, I'm going to move to a different app. I have another one running here. Let's take a look. I guess we're showing that we're definitely doing a live demonstration here. There we go. Okay, let's try a different app. 1 second. All right, hopefully you can see it now. This is the actual console. I apologize about that. For some reason, I'm running into issues showing our virtual labs today. The virtual labs are available from our website, and you can access the infrastructure at any time through the virtual lab. But here we have the console, and the console itself is loaded on my computer here, and I'm connecting to a remote data center. In this data center, I have a single cluster. On that cluster, I have 3 Hyper-V hosts. And if I go to the Hyper-V Management tab on top, I can look at all the virtual machines running within that cluster. If I had other hosts, they would just show up down here, whether they're in different clusters, maybe even located in a different data center. But more important, let's look at some of the things you can do. And all these functions that you see here are available through the API also. So you might have support systems in place, let's say like a ticket system. And you can set it up where if a monitoring alert or something happens, you could potentially start this virtual machine or stop it. You might have deployment scripts that you're running today that you can then use to create a template. For example, I'm going to create a template of this virtual machine here. Select the template option. I can do a template based on that machine. This is the location I want to store, and I can export that machine out. It's going to create a template for that machine. And then I can very easily come in here, say create VM, and create a virtual machine off of that template that I just created. Now the create VM process is also part of the API. And I'll show you how that works a little bit later. But you'll see that you have 2 options. You can either create a blank virtual machine, or I can create one from a template. One thing I really like about the template option is here I can select my template storage, but in a multi-tenant scenario, or potentially in some companies, you might want to limit what templates a user might see. So I'm logged in as a global admin right now. I can see all the templates. But if I created a user, either through the API or through our console, I can create that user so they're only going to see the templates or the storage locations that I assigned to them. So that makes it really easy. You can create a user that's able to come in here and deploy, for example, a simple Windows 16 machine that you have already pre-set up for them. At this point, they can select, for example, this Windows 16 Data Center desktop, push finish, and it will deploy that machine onto this environment. You can also provide sysprep options for this. So while they're deploying it, it might ask certain things like what is the domain name, the CD key that you might want to provide for this. I'll show you that here. So here's the guest options. So here, before you deploy this machine, you could specify the computer name, the password, product key, obviously any domain or workgroup information. And you can go ahead and pass any other details or just push finish and it'll deploy that template. If you right click here, you also see some other options. We're going to be able to correct checkpoints from the machine. Console connections. So you can easily connect to the console of the virtual machines. This is a true console connection. It's not an RDP connection. Because of the way the GoToMeeting works, that the console pops out into a different screen, so you're not able to see it through the GoToMeeting. But technically what it does, it's actually creating a console connection to the hypervisor, and the hypervisor then shows the console to you. So one thing I really like about it is I don't even need to enable RDP on a virtual machine in order to connect to the console. So maybe for security reasons, you want to disable RDP. You'll still be able to get to that machine using on top of that, obviously, we can attach different ISOs, and I can live migrate machines too. So this WinCore machine here, if I wanted to, I can see what it's running down here, but I want to move it to another server. Just easily live migrate it to another host. This could, again, be another good place for an API call. So let's say there's a situation where you need to move a machine. If you want to automate that process for any reason, you can do this through the API. What it's going to do, it's going to take that virtual machine, live migrate it up and over to a corresponding host for you. And it does it while the machine is running. The machine never actually stops. And of course, we can replicate to the hosts also. So when you replicate, you're able to replicate out to another hypervisor. Obviously, the hypervisor needs to be running HyperV, but it doesn't need to be in the same location. And in most cases, it's not going to be. You want your replication host to be in a different site. But what we can do is we can replicate these virtual machines to a on-premise hypervisor. So I can take this machine and potentially send it off to a co-location center. But we also have the ability to replicate the virtual machines up into Azure. And so this is important here. A lot of places that I'm seeing this being used throughout our clients is basically twofold. They have, they're either doing a hybrid scenario where they have some machines on-premise and they have some machines up in Azure. Typically, I've noticed that it's either one of the two. They're putting the high-intensity machines up in Azure to get that initial, bandwidth and get the CPU resources that you can pull from Azure. The other thing they're doing is they're setting up their test workloads. And of course, I'm sure everybody on the call has worked with people before that don't want their data in Azure. So they still want their information on site. So replication plays nice to that scenario where you can have the virtual machine here on site. So that you still have your data on site, it's in your building, but you can replicate this virtual machine to Azure. So if anything ever happened in that building, you can turn it up in Azure. And once you do turn it up into Azure, you can then replicate it back and forth. So for instance, if you replicated it up to Azure and you failed over that VM into Azure, it would show up here. And once you're done and your on-prem is completed, you can easily reverse that replication, and now it's coming back down on site. So I consider that maybe like test workloads or temporary workloads. And I see a lot of use for Azure and our tool set for that. And in the management, Azure management part, you can see that I'm very easily able to start the virtual machines, and I can access different features of those virtual machines. Like I can view the real-time information of statistics of how they're doing. I can create alerts, view different metric alerts. For example, here's the disks, the operations, the networks, and the CPUs of that virtual machine. I can create different alerts. I can add a metric or log activity alert. Metric alerts would be if this disk reaches 800 megabytes to send me an alert, or if this disk is spinning IOPS too fast, set a threshold, send me an alert. Log activity alerts are alerts based on different logging events. For example, it could be simple as someone logs into the virtual machine, or it can be some sort of error or corruption on that virtual machine. It's depending on what the logs are showing. Up here we have the import virtual machine option. So here, this is a little different than replication. So replication is going to give you that real-time, always connected, sending the blocks up to the replica as they're being written to the primary. The import virtual machine is going to take a virtual machine that's on-prem and send it up into Azure. And it's going to take a copy of it and put it up there. You can then spin it up. This is very important for clients that are looking to migrate to the cloud or are looking for an easy hybrid scenario where they can take virtual machines that they want, very simply right-click, find the virtual machine. In this example, I use this Windows 4. Oops, has to be stopped. You'd select which resource group you have in Azure. You'd select your location in Azure. You would select the different storage account you want to use. All these are pre-configured in Azure, or you can create them through our software, obviously. You select the basics here would be the name of the machine. Next is the size. So it's really important. So when you're importing this virtual machine, it's only going to fit within particular Azure VMs. So what we do is our software is going to determine which sizes are most suitable for that virtual machine, present them to you, and we hide unsuitable virtual machine sizes. So you would select which virtual machine size to fit that in. Next option, you'd specify what IP addresses you want to use up in Azure. So once this machine is sent over into Azure, this is the private IP space you would put it on. Do you want to give it a public IP or not? And you need to tell it what type of system it is. Once you do that, it's going to go ahead and take that virtual machine and send it up into Azure. So that's the Azure management. Obviously, we support multiple subscriptions. As you can see, I have 2 subscriptions in here. That might be for clients that are supporting multiple subscriptions. Obviously, you can have them all standing here, or you can put all your machines in the same subscription. So monitoring. Monitoring is going to be a big part of the API, in my opinion. It's going to provide you a way to pull information on various aspects of your environment. So you're going to be able to pull the health of the hosts. You'll be able to pull the health of the virtual machines. You're going to be able to pull the health of the cluster, which is, out of all these, it's the most important. So if you're running clusters, you know that that cluster is the is what's driving everything. And those cluster disks, for example, your CSV volumes. Those CSV volumes, our software keeps an eye on. We monitor things like free disk space, IOPS, redirects, queuing. Basically, redirects and queuing, you definitely always want to keep an eye on. That is definitely a sign that something is going wrong, potentially with that CSV volume. And we do this over benchmarks and times, too. So here on the demo cluster, if I click on the actual demo cluster layer here, you'll see it's showing me my 2 disks. In this example, I have 2 tiers. I have SSD and SATA. We do support storage spaces direct. In this environment that you're looking at today, I don't have storage spaces direct enabled. Our virtual labs on the website does. So if you're looking for an example of that, I can show you. And down here will be any alerts that are coming up for any machines in that cluster. I can pull up the cluster disk itself up here, and I can look at the cluster disk. I can select which volume I want to look at. I can look at these different metrics here, and I can look at them over periods of time. So being able to, for example, take a look at how your IOPS on one of your volumes has been performing over the last 3 months is very important information. You know, it's going to tell you the direction you're going on your cluster. Maybe you need to move some resources to a different volume. Has your free space been growing out of control? So all this data here is available through the console, but we're also exposing it now through the API. You drill down to the actual HyperV hosts here and go to the summary page. You take a look as you click through the HyperV host. You're going to get any alarms that are showing up for that particular host and any of the workloads on that host. You're going to see the real-time information for the host, and then you can drill into this information a bit more. So, example, if you wanted to look at the disk, you can easily drill into the disk of this machine. Just like the cluster volumes, I can take it and look at it over the past month, or even put historical data. So now we're looking at this time frame right here. And I could look at these different areas and get an idea of how this disk is performing. Same with the CPUs and different metrics. One thing I like about the CPUs here is we're actually breaking out the different types of CPUs inside of your hosts. So your host is basically supplying three different, the CPUs are being cut out into different areas on the host. So the host itself is using CPU to run the host, its operating system. It's also dedicating some CPU to the hypervisor availability to the machines as they need it. And it's also providing some CPU down to the virtual machines. So that's what this is representing here. It's showing you that breakdown. Up here are some predetermined alerts. So we do have alerts and logging. You can collect this alert data also from the API. So as I set these alerts in the software, if this machine would spike, for example, up to 60%, it's going to create a warning event in our software that includes an email and a logged entry. And if it bumps all the way up here, it's going to create an error alert. These are lines that I preset, and you can set all these different actions, and I'll show you that. And at the VM level, obviously, we're tracking the VM itself. Again, you see the alerts. And one thing I like about this is we can take a look at both the hypervisor and the guest CPU usage. This is kind of also unique to our software, where if you have the hypervisor is only going to give you the, if you ever look at native HyperV, for example, it's going to show you the hypervisor's CPU percentage. It goes back to what I showed before. It's going to show you what the hypervisor is giving to that machine over its total amount available. In that case, for this, looks like it's somewhere around 2%. But that doesn't actually directly correlate to what the guest CPU is doing. So that guest CPU only has one CPU core. And that one CPU core, for example, if I went into Task Manager on that machine, it would be running somewhere around 25%. So you really want to monitor this area guest CPU, because at times you might look at the CPU. If you're just looking at hypervisor, it doesn't seem very critical, but the guest CPU usage in this example might even spike higher than this. So it's, this data also, guest and CPU, will come out and be available through the API. That's a quick look at the monitoring aspects. One thing also is dynamic optimization. This is going to be big through the API because you can easily optimize now the cluster. So you can send one call to our API to say optimize, run once. And it's going to take the virtual machines, it's going to take a look at how the resources are allocated throughout this cluster and live migrate the machines that it can to various nodes in order to level out that cluster in terms of resource utilization. Very powerful command that can be sent very simply. And here you can do it through the console by clicking that. So the reporting aspect, reporting data is reporting on how you're utilizing the resources that you have assigned. So I'm going to spend too much time in this, but what I want to point out is the main purpose for this. So in this example here, I have my CPUs, and this is over the past week. I'm going to go up to the data center layer. So if I click at the data center layer, it's going to show me the report for the entire environment over the past week. I can change this to the past month, or even put a custom time frame in. So the software is going to use its algorithms to determine how the resources are being applied in the environment. In this example, it's finding some disks that aren't attached to VMs. It's showing your dynamic memory usage and your static memory usage. Some examples here might be, this is actually pretty much in line because I recently right-sized these VMs, but in customers' environments, it's very common once they install the software, and I suggest everyone on the call to, go to our site, you can trial the software. And when you run this report, you got to give it about 24, 48 hours for it to collect the details. Once you'll start to notice, it's going to identify machines here that you might not have assigned properly. So in a lot of cases, I might see where they have assigned 2 gigs of memory to this machine, but over the last month, on average, it demands 4. So it's telling you that you need to obviously give more memory to this machine. But the other place where this helps, it shows you the reverse. So in that case, I might have a machine up here. And this is a bad example because all these are pretty good right sized. But I might have a machine here that I assigned 20 gigs of memory, and it's only demanding 10. So typically as administrators, what we do is if I saw this machine in the past, and I saw a machine that needed more memory, I would just open up settings, give it more memory, and it would just come from a free pool of memory, or I'd have to call a vendor to get more memory. The object here is actually take that memory and find it in your environment where it's not being utilized. So you don't always have to grab free memory. You can do that between your static and your VMs. So you're basically right-sizing the virtual machines. Same goes for CPU. You might have a machine up here that is pushing 25 or 30% CPU average over the last week or last month. And then you have a machine over here that's doing 0.131. What I would do is I would take a CPU core or 2 from this machine because it obviously doesn't need it, and I would give it to this machine. So again, instead of just adding more CPU cores, you're actually taking the CPU cores and moving them logically throughout your environment. And obviously we have different reports, VM sprawl and CSV volume growth. Backup is available through the API also. So you can monitor backups through the API. You're going to be able to kick off backups through the API and restore virtual machines. All this can be done. And so the way the backup works is we create backups of the virtual machines. So you're able to either restore the entire virtual machine, or you can restore just a copy of that virtual machine. You can send that copy to any location, or you can overwrite the original. The other option you have is to extract just one file from that backup. So we do file level backups also. We encrypt the backups and we compress the backups as an option. And you can send the backups either to local storage or you can send it up to Azure Blob Storage. Again, if you're going to POC or test this product out, which I also suggest if you don't already have one, is to create a trial account at Azure. You'll get free credits, and you can also test out all these different environments with Azure. You can test the hybrid scenario with those trial accounts. That's if you don't already have an Azure account. You can also back up your machines and test that scenario. This also gives that hybrid redundancy and also data recovery availability. So you can back up to on-prem and back up to Azure at the same time. We also give you the ability to specify how long you want to store those backups in each location. I consider Azure an example backup as almost DR for my primary. So most administrators store their backups in the same location as their Hyper-V hosts. Kind of scary, but it's true. Some have off-site locations that they copy those backups to nightly, something to that effect. And that's kind of what I wanted to show you here, is that this backup is going to give you the ability to create backups locally in your environment. But most importantly, it's going to take a copy of that backup and store it in Azure. So if anything ever happens to the local building, you could very easily restore that, that backup. And it gives you the ability here. You'll see I'm going to select where to back it up. I'm going to put my Azure Blob Storage key in. I then specify how often I want to back up. I'll just back up every day. And all these options are available through the API. I then can do a full backup or incremental. This example, I'll create a new archive every 5 days. But this is really where I was getting at before. So if you want to keep those on-site backups, this is the on-site area on top right here. So it's very important because it's great. If you need to restore that virtual machine, it's going to be very fast. It's on site. It will restore quickly. But if anything ever happens to that building, you're going to lose your backup. So what I also suggest is using Azure. You might store it up in Azure for 3 days, just as a DR for this right here. So it's very powerful. And obviously, as I said, you can restore those different backups. The administration area here is where we create users. So through the API, I'll show you, you're able to create users. You're able to create tenants and roles. And this is how we give that multi-user, multi-tenant access to this environment, is by creating the users, either Active Directory users or just regular one-off users. As I specified earlier, in some cases, you don't want to give out Active Directory credentials in order to access the environment, and you don't. So you can either create a custom user or a user from your Active Directory. And then you assign those users a role. And when you assign a role here, basically what you do is you give that user and you're going to tie him to one of these roles. And so as you see, everything I check here is what they're able to do. So through the API, you're able to call this. So if you already have some kind of system in your place today when you're onboarding a new employee or maybe an administrator or something to that effect, you could tie it into the system to instantly give them the access. Otherwise, if you use Active Directory authentication, you can very easily just add that Active Directory account to this console or through the API and then assign one of these roles to. So for example, if I didn't want this person to be able to delete virtual machines or shut them down, I would uncheck, which this is not checked. But if I want to allow them to connect to the virtual machines, like through API, through RDP, I would specify connect. And that's a multi-user aspect. They load the console. Once they load the console, they'll supply their username and passwords. And we also have the notifications. So I just wanted to point this out real quick. This is also going to be available through the API. But if you want to receive email notifications, you can. These are the alerts. So this is where you're going to set the thresholds that create those alert scenarios, either on the hosts, the VMs, or the clusters. And we can do that through event alerts. These are Windows events. And the backup and replication notifications. Very important. You want to know if your replications are not working for any reason. This is going to notify you, create alerts in our software, and you can collect this detail through the API also. Just one other piece, the SDN. The SDN piece I have running in our virtual lab. Go ahead and give another shot to move over to that. If not, then we'll jump into the API and I'll show you how that looks today. In a second, I'm going to try to demonstrate the SDN bit. Okay, so yeah, I'm going to go ahead and move over to the let's take a look at the actual API real quick. One second. All right. Hopefully my screen's coming in now. Let's see. There we go. So as you see the URL up above, oops, I don't know if it's sharing it. There we go. So as you can see up above, we have the URL, swagger.five9.com. This is the current location for the API. So this URL is, the sole purpose of this right now is just to give you, to show you what's available in the API. So just to back up a little bit, Swagger is a framework, if you're not familiar with it, for documenting an API. It comes in the form of a JSON file, swagger.json. And what's going to happen is when you install Five9 Cloud Manager, our up and coming version 3.3, this environment is going to be available local on the management server. So what it does, if in another area of Swagger, you can actually create this based on the type of code you're doing. Let's say you're coding in Android, or you're coding in ASP.NET Core or PHP. Swagger can provide you examples for all of those different programming languages solely based on the Swagger JSON. So here what we're looking at is the different types of functions that you can call. So if we start on top, we have obviously the categories, but we'll move right down the cluster. So we saw the cluster before. I'll be able to get a list of all the clusters. I can set the settings of the clusters. I can pause a node, resume a node. And if you click into each one of these, you'll see that what it's going to show you, it's going to show you the command that you're sending and the response. So in this case, this get, in order to get a list of all the clusters, doesn't require a parameter. And so once this is deployed in your environment, so once you have Five9 Cloud Manager 3.3 installed, you're going to be able to open up the Swagger document, and you can do things like, say, try it out and execute. And it's actually going to execute this API call on your local environment. And it's going to show you the actual call that it makes. In this case, I'm just using curl. And it's going to show you the request that it sent, and it's going to show you the response. In my case, I don't have a response because it's not connected. But if it's local in your environment, it'll be connected. And it shows you the actual response header here of what's expected to be returned. So it makes it very easy to quickly develop on the API. So you can come into this, this environment here and test out different API calls, see the responses. It also documents all the different areas. So discovery. Discovery would be the location where you are adding HyperV hosts. So if I want to add a new HyperV host to my environment, I would call the discovery method, and it would get the details for that Hyper-V host. It's going to add that Hyper-V host into the machine. It can also select different details and collect different details about that host. Here, for example, is how we install the agent. So if you want to, you can actually make an API call to go ahead and actually add a new Hyper-V host to your environment. Event alarms, as you saw, are different alarms that are coming up. So every time that there's a cluster alert, VM alert, you can get those alarms through here. You can also set different alarms and mark alarms as resolved. So you might have a system in your ticketing system, maybe that's you want to pull in the event alarms for a particular VM, associate them to a customer maybe. And then once you have identified those or looked at them, you can then go ahead and mark them as resolved. You'll see in this example, what it's saying is it requires an integer. I'll go ahead and say try it out. And this is, again, the way it would work. You would, if you wanted to test this out internally, you would type the ID in, execute, and it's going to attempt to execute that command on the system. It's going to show you the different responses you can select. If you wanted to see PHP or different options, these are available. I'm just using the basics right now. So going through the host side, so on the host here, you're able to see, we're able to take a look at all the different areas of the host. We can create new virtual machines. When you create the virtual machine, this is an example of the parameters that you're going to send to that virtual machine. And this is an example of the response that you would get from that machine being created. You can import virtual machines. So all this can be easily be done from API calls. You can actually create your own control panel if you wanted to at this point. Maybe you have a client you might be dealing with today has a unique need where they need a system to import virtual machines and export them. You can create a simple application for them to do that. You can inspect the virtual machines. Here's the templates. You can look at all the template information. So it's fully featured on the host side and on the VM side. Here's the logging. Licensing is licensing. Logging, we can collect details about the logs. We can download the complete log package. So what these are actually system event logs. This is actually more hardware-based. It's going to tell you how the agents and the hypervisors are running more on a hardware base. Obviously, you have your notifications. These are all those notifications that are coming out. A notification would be something like, as we looked at earlier, a backup has failed. some kind of alert or warning that are sent out by email. You can also schedule reports and schedule notifications. Remote desktop gateways, resource pools, storage locations. You can create storage locations. You can monitor your storage location. You can get details about it, for example, the space and stuff like that. Update version. It will download the actual console installer and update the software. So that's the actual update mechanism. If you wanted to update the software without even actually opening the software, you can do that. User group settings. So here's where we're actually adding users and groups and assigning them to roles. So you kind of saw that earlier. That's through that. Here's the VM areas. So throughout VMs, we're running through snapshots, creating VMs, getting info about the VMs. VM switching. So you can even create virtual switches through this. Authentication. This is how we authenticate for this API. So we're going to provide a primer with this. I don't have it here in front of me right now, but this I'm going to tell you about how to authenticate and use this in order to integrate with the API. It's the key authentication. Job details. This gives you details about every single event that has ever occurred inside of your environment. User A has started this VM. User B is logged in. This VM was started. This VM was deleted. All that data is stored for compliance and many other reasons. We can easily pull that out here. All the tenant information. You can create custom users, create schedules. You have reporting. Here's that optimizer I spoke to you about. So the optimizer itself, you can call it and run it. You can set the optimization and you can even invoke it. You get summaries, metrics, archives. So this is the backup area. So if you wanted to have your own backup UI or maybe integrate into some existing systems you're using today, you can do that. Call the backups, use backups, deploy templates, create templates. SDN. So we have the full SDN environment here that you're able to easily go through and deploy and look at different areas of your SDN. SDN is kind of complex, as you can tell throughout all the API calls that we had to create in order to provide that ability, full-featured, and do everything that's needed through SDN. And then the SDN deployment. You can actually deploy SDN through the API. So that's a quick look here of the Swagger and our API implementation. We're going to do a follow-up webinar soon where I'm going to dig into these actual API calls. We'll do some things live, like create a virtual machine and stuff like that. But yeah, I'm going to go ahead and pass back to Vince at this point, and I hope everyone enjoyed my presentation today.
Okay, great. Thanks, Rob. So with that, we're going to look to wrap up, but a couple of questions that we'll probably want to address here before wrapping up. Here we go. So here's one that just came in. Rob, it's probably best to address this. Is this URL that you just showed publicly available for me to start understanding the API?
Yeah, absolutely. That JSON file, the swagger.json that you see, and that URL is available. It's going to give you details about the parameters that you're going to send and the responses that you're expected. But you're not going to be able to execute on those. So you're not going to get real data back, unfortunately. But yes, you can dig into this in order to get an idea of what is available and how you would call it. It's going to show you the parameters and the expected results. If you go to the Swagger website themselves, Swagger would allow you to also take this JSON file and you can export it in different formats. So if you are programming in PHP or Java, you can get the examples of this in those different programming languages also.
Okay, great. As far as availability, there's a couple of questions out here for the availability. So as Rob mentioned, version 3.3 will be released probably in the next week or so. We're targeting end of January, which is end of next week. Within that release, you will have the full API coverage that Rob walked through today. We will be providing sort of an on-prem instance for you to be able to run within Cloud Manager. And so when you do that, you'll be able to run it localized. And then we'll still have this URL up for more for reference and viewing purposes, but you'll be able to run it locally within the 3.3 release when that's made available. Next question is on the granularity of administration. Are all the functions, so Rob, are all the functions of administration available through the API?
Yeah, that's correct. You'll be able to create a user. You'll be able to assign that user a role, and then you could specify what availability is inside that role. Just as you saw me checking those boxes, you're going to send those over through the API as a Boolean, true or false. Can he shut down the machine? Can he connect to the console? So yeah, it's fully featured.
And that's really useful for like a managed service provider, right? To be able to leverage that and maybe use those APIs for setting up roles within their infrastructure, via their own portal that they might have, for example.
Yeah, absolutely. Or another great example of that would be, let's say the MSP has some sort of automated provisioning system where a customer might go to their website and order a server, a VM. And you can use that automated provisioning system to instantly deploy that VM and give him permission to that VM, all through the API.
Okay, great. So we are targeting our next webinar, I believe, for 2 Fridays from now. So that would be February 8th. During that February 8th webinar, we will already have 3.3 at a GA state, but we will be walking through the other 3.3 features and then also be in a position to run the API as well versus just showing it. So we look forward to you learning more about Cloud Manager in that upcoming webinar, where we describe additional features and capabilities that we're working on to provide you with additional efficiencies, operational and cost. So thank you for your time, and thanks, Rob, for walking through everything. And we look forward to seeing you guys soon. Thank you.